So now we can apply those ecological principles that we've just learned about, and we're going to apply them to the human population. We're going to cover these learning outcomes and make sure that you're covering these as you're using these to study, because these are going to be used when I build the quizzes and exam questions. All right, so here is a graph that shows the human population globally over the past about 10,000 years or so. There's a little video linked in the lecture slides, and I'll also put it in the playlist for y'all about the changes in human population. So what we can see is for a long time that the human population was pretty steady. We do see this gradual increase. Here we see a little dip in the human population, and that was corresponded to the bubonic plague that killed about a third of Europeans, and that's the only time we see a dip in the human population. But about 200 years ago, we see a huge population spike about the time of the Industrial Revolution. So do you think that this graph is going to looks like a logistic growth curve or an exponential growth curve? And as we're thinking about human population, a thing that we need to be thinking about is carrying capacity. What is the carrying capacity for humans? It kind of depends on how many resources you're using. Have we already overshot that? And if we have, what does that mean for the future of our species? So we can look at these age structure charts like this that can give us some insight in how populations are changing over time. So we're looking at the populations of Nigeria, the United States, and Germany in 2020. And we, so along this x-axis of each of these graphs, we see the number of people in millions who are biologically male, those that are biologically female, and the y-axis is showing us their age. And so we can kind of look at these and compare these age structure graphs from Nigeria, the US, and Germany. So let's focus in right here, though, because since we're in the United States, let's talk about those guys first. Okay, we see that there's a very few people that are 80 years or older. Females tend to live longer. Sorry, guys. And there's lots of young adults that are kind of in this 20 to 35, 40 range. And we can also determine from this graph that our birth rates have dropped in the past couple decades because there are fewer kids than there are young adults. So we can use these age structure graphs to get an idea about how populations are going to change, looking at these age structure diagrams. So rapid growth, like we see in Nigeria, means that there's a lot of kids, right? We have a high birth rate. On the other end of that spectrum, what we see in Germany is a declining growth rate. So we see, again, a lot of these young adults, but fewer kids, relatively speaking. And so we can use that to make predictions about how the population is going to be in 20, 30, 100 years from now if those population changes, right? Our R value continues the way they are. We're going to see a lot more people in Nigeria than we are going to see in Germany. Okay, and we can use these then to predict future social issues. So in Germany, as these people who are in their young adulthood, middle age, start to become older, they're going to be retiring, and there's going to be fewer workforce. So how are we going to deal with that challenge? Right? How do we deal with the challenge of a significantly larger Nigerian population when maybe we don't have the resources to feed and house and clothe all those people? All right, so we get this, for humans, we can use this total fertility rate to make predictions about the changes in the population. And our total fertility rate is the average number of children that are born to a woman. And so, sorry guys, you're not really included in how population growth occurs because male reproduction is not the limiting factor for how many kids are born. So the replacement value for humans is 2.1 children per woman. But hold on a second. How can a woman have 0.1 kids? I mean, unless you're Marge Simpson, of course. But what we need to do is remember that the total fertility rate is an average. So if 9 out of 10 women have 2 kids and 1 out of 10 women have 3 kids, then of those 10 women, then their average number of kids is 2.1. And that means that our population is going to stay the same, not going to grow, not going to shrink. So let's look at these total fertility rates globally. And what we tend to see is that overall, we see the total fertility rate across the globe is dropping. So the red bars are showing fertility rates from 1970 to 1975, and then the blue bars are from 2015 to 2020. And in all cases, we can see a drop. And we see our biggest drops in Latin America and Asia. Africa still has a pretty high total fertility rate. Most parts of the world are near or below the replacement value. So if we're concerned about having enough resources for humanity, we might need to think about how can we lower those total fertility rates. And some ways that we can do that is make sure that there's secondary education available for all people, especially for women and girls. The more education women and girls have, the fewer kids they tend to have. So without a high school education, on average, globally, women have 5.4 kids. That's their fertility rate. But with a college education, it's globally near that replacement value of 2.2. So we're pretty close. Similarly, when women have equal rights as men, family sizes tend to be smaller. So making sure that women have access to own property, to obtain divorces, get credit, all those things, so that we can make sure that our human population is staying at manageable levels. And of course, having government-sponsored family planning programs is going to reduce fertility rates. So a few examples: in Thailand, fertility rates dropped by 75% in just 2 generations after the government there sponsored family planning. So just providing birth control, condoms, other means of choosing when kids are going to be born.